Hey guys, welcome back to a brand new video. So today we are gonna solve the LeetCode problem 1061, lexicographically smallest equivalent string. So first we will go with the problem description. You are given two strings of the same length s1 and s2 and the string base string. We say s1 of I and s2 of I are equivalent characters. For example, if s1 is equals to abc and s2 is equals to cde, then we have A is equals to C, B is equals to D, C is equals to E. So equivalent characters follow the usual rules of any equivalence relation. Reflexivity, symmetry and transitivity. Reflexivity means if A equals to A. Symmetry, if A is equals to B implies B is equals to A. Transitivity means if A is equals to B and B is equals to C implies A is equals to C. Okay. For example, given the equivalence information from S1 is equals to ABC and S2 is equals to CDE, ACD and AAB are equivalent string of base string EED, and AAB is the lexicographically smallest equivalent string of the base string. Return the lexicographically smallest equivalent string of the base string by using the equivalency information from S1 and S2. Okay, now we'll go and we'll take an example and we'll understand how it works. Okay, so I have taken one string, that is Parker, and the string 2 is Morris. So now we have to compare the each character of the string, like P is equals to M, and we need to keep in mind we have to take the smallest letter first. So in between these two characters, when we compare, the smallest letter we need to make it as a leader to make the final string. Okay, so first we'll start with the P. So P equals to M, and then A equals to O, then R equals to R, okay, and K equals to R, E equals to I, R equals to S. Now we can clearly see R equals to R is the reflexivity, K equals to R and R equals to S. That means K is equals to S because it implies the transitivity. If A is equals to B and B is equals to C implies the A is equals to C. So we can clearly say that if R equals to R is R and K is equals to R and R equals to S, so we can combine all three and we can make it like this, K which is equals to S. Okay, yeah. Now we need to combine both of them and we need to make sure that the smallest alphabet would be the leader. Okay, so smallest alphabet comes first, so M comes first and then comes the P. Now in the A and O, A comes first, then comes the O. In R equals to K equals to S, K comes first, then R, then S. In E and I, E comes first, then comes I. Now we need to compare this base string to the this group of alphabets, and then we need to find out the lexicographically final smallest string. So in the P and M, M comes first, so this P will become the M. Between A, so it is always A, and in the R space K comes first, so K, and in the S space K comes first, so K, and E obviously E because E is smaller than I, so E, and in place of the R, K comes first. So our lexicographically smallest string is MAKKEK. If they have asked lexicographically largest string, then it would have been reversed. It would become POSSIS, but they have asked us to lexicographically smallest equivalent string, so this is the final string. Okay, now we will code it. Okay, so before starting I will take an global variable and I am going to name it as the parent is equals to new in, and the size would be 26. Okay, now we'll start. Now I'll store the index from 0 to 25 in the parent array, where 0 means the small letter a and 25 means the small letter z. Okay, so to do that I will use the for loop for int I is equals to 0, I is smaller than 26, I plus plus parent of I equals to I. That's it. Now I'm gonna perform the union operation on each characters of the two strings. Okay, now to iterate throughout the string I need a for loop. So for int I equals to 0, I is smaller than s1 dot length I plus plus. Why I'm considering only s1 dot length is because they have clearly mentioned two strings of the same length s1 and s2. So that's why I need not to worry about the s2 length, it is equal. So yeah, now I'll call in function named as union. I will pass the character s1 dot character at I. Then I need to convert it to the integer, so I'm gonna minus it, subtract it with the a. Then I'm gonna pass the s2 dot char at I subtracted a. So this is the function. I'm gonna tell you why am I using this and what is the role of this. Okay, so it will go through the each part of the character in s1 and s2 and convert the character to the index. To convert it, I'm gonna subtract it with the a. So it will convert the character into the index, that is from 0 to 25, and it will pass to the union function. Now we'll go and we'll write the union function first. So I'll take as the private function, private, it returns nothing, so void union int x comma int y. So it also need two variables to keep track of the path. So int root x, so I'm gonna find the path, so I'm gonna call in function find, I'm gonna pass the x. So another int root y and find the path, so find y. Okay, now if we consider here, when r equals to r, we must return the r, and if any alphabet is smaller, then we need to write the alphabet, smallest alphabet first, and the greater one would be us. So we're gonna design the three condition. Okay, first one, if root x equals to root y, then we must return the same way, so just return. Otherwise, if root x is smaller than the root y, then we need to update the parent, which is root y is equals to root x, the smallest comes first. Otherwise else we need to update the parent, which contains the root x value, to the smallest one, root y. Yeah, we're gonna design the find function. Basically it is a path compression. So path compression, so we're gonna take the private only. Private, it returns, so it is returns integer value, so private int find int x. So yeah, so now I need to use the recursion, so it calls itself only in condition if parent x is not equals to the value x, then we'll update the parent value of x is equals to, and I'll call the function again find parent x. Yeah, and after that it will return the value. So return parent x. Yes, done. Now we're gonna build the string. So build the string. So I'm gonna take the string builder, string builder, I'll name it as SB is equals to new string builder. Okay, so now I need to iterate throughout the base string, and I need to compare the character with the union of strings, and then I have to find out the smallest element, smallest alphabet, and then I have to make the final string. So to do that I'll use the for loop for character C present in the base string. I'll commit it to the character array to char array. Okay, I'm gonna open the bracket. Now I need another variable to store the character, and I need to store the smallest character. When after comparing, see, after comparing with this and this, I need a variable to store the smallest letter m. So I'll take another character, I name it as smallest character. Now what I'm gonna do is we need to find the smallest element in the two union string, and I need to return the smallest string. So to do that we have already used the path compression code over here. So I'll just call the find, then I'll pass the character, and then I need to make it as to the integer. So I'll just do one thing, I'll just subtract with a again after coming back, and then I have to convert it to the character. So I'm gonna just use one thing, I'm gonna just use char over here, and I'll just make it as a single function. So yeah, now it's done. Now I need to append the smallest character to the string SB. So SB dot append, we're gonna add the smallest character. Yeah, that's it. Now I need to return this final string. So return SB, and I have to convert it to the string, from the string array to the string. So SB dot to string. Yes, that's it. Now we'll just try to run it. If we get any error, then we'll just solve it out. Yes, now it's passing all the test cases. Now we'll just submit it. Yes, it's accepting, and the streak continues. Yeah, thank you guys for watching this video. If you really like this video, please do like and subscribe for more videos. Thank you.